Hi everybody, this is Julian from Arcee. Just a few days ago, we launched our new SaaS inference platform called Model Engine. Model Engine introduces a new collection of Arcee models, and in this video, I'm going to show you what those models are. We'll talk about their benchmarks, how they compare to models that we've previously built, and of course, we'll run some demos using the model APIs. Okay, let's get started. To get started with Model Engine, you need to go to models.arcee.ai and you need to sign up. All those models are commercial models, so you can sign up in a minute, enter your credit card details, and you're good to go. Our current plan starts at $20 a month, which buys you quite a ton of credits that you can then spend on those different models according to their different prices. And we'll look at the prices as we move along. So what models are available today? We have three different models. We have Virtuoso, Coder, and Coder. Virtuoso is a general purpose model for conversational apps. It comes in three sizes: large, medium, and small. Coder, as you would expect, is a code generation and code conversation model. It comes in two sizes, large and small. And last but not least, we have a model called Coder, which is optimized for function calling and working with external tools. And at the moment, it comes only in a large size. We have more models coming very soon. In fact, by the time you watch this, they may already be available. If you look at our launch blog post, of course, I will put the link in the video description. You will see that we have two more models on the way, a model called Spotlight, which is a vision language model, so multimodal model to work with images and text. And we have a reasoning model called Maestro. Okay, again, by the time you watch this, they may be already available. So feel free to go and read the blog post. You'll see some benchmarks. And in fact, before we dive into testing the models, I wanted to show you how those models compare to some of the previous models that we've built. Here you see benchmarks from the Hugging Face leaderboard for three of our open source models: Llama 3.1, 8 billion, Supernova Medius, 14 billion, and Arcee Nova, 72 billion. And all those three models are open source as well, and you can get them on the Hugging Face Hub if you'd like. And you see numbers for Virtuoso Small, which is 14 billion. We can see two things here. If we compare the two 14 billion models, Supernova Medius was released not even 2 months ago. And you can see how Virtuoso Small outperforms it very significantly on all benchmarks. So this shows you how fast we are moving and how fast we are improving our models. And again, this is just the small one. We can also see that Virtuoso Small is getting dangerously close to Arcee Nova 72B. And when Nova was released in last July, it was the best 70B class open source model. And now we can build a 14 billion model that is almost as good, right? IF eval is actually higher. Big Bench Hard is a little lower. And the other benchmarks like maybe MMLU Pro are pretty close as well. So is 14B the new 70B? Not quite, but we're getting really close to that. So you can imagine what performance you can get from our larger Virtuoso models. Okay, and the increased cost performance and the increased ROI you're going to get, because in terms of infrastructure deployment, working with 14B models is much simpler, much more cost effective than working with 72B. Okay, so that's where we are today, and we're nowhere near done. Let's take a look at the models now. Maybe we start with Virtuoso Large. Okay, so you can see the prices. So $1.27 per million input tokens, $1.50 per million output tokens, and context length is 128K, right? And this compares the other models in the family. So large is 72B, medium is 32B, and small, which we just looked at and said it was close to other 70B models, is 14B. Okay, so you can see all those prices. So let's just go and ask a question. I don't know, what should we ask? Oh, here's my favorite prompt. Hope you're not getting tired of it. Okay, so let me zoom out maybe a tiny bit. Yes. All right, so we can see, it's working, it's generating, it's fast, great. We generated 604 tokens. And if we look at usage, we'll see for each models that we used here, how many queries we sent to the model, how many input tokens we used, how many output tokens we used, right? So I've been playing with this a little bit. And we see the cost for 1 million input plus output tokens, okay? So don't worry, you didn't spend 2.77 on 46 queries. So once you spent 2.77, you will spend another 2.77 on another million input plus 1 million output tokens, okay? And you can see the price for the coder model. Good. By the way, you can see your payments here, right? So I paid for $20. My balance is $15.74 because again, I'm in the process of spending, $149 plus $277. Okay, that's how it works. Good. Let's go back to models. Okay, let's go back to large. So, we can play with this in the sandbox, get a feeling for, the performance of those models, but obviously we want to work programmatically as well. So being a SaaS platform, Model Engine lets you query the models through APIs, and you will recognize the familiar OpenAI format here for URLs and the payload. One thing to keep in mind is we use HTTP2, which is much more efficient. So you need to make sure that you're enabling HTTP2 for curl or for the OpenAI client, which I will show you in a second. Okay. Of course, you need to pass your authorization token, your API key. Okay. So don't forget to create one in API keys here. Obviously, I already have one, but just click on Create API Key and you set the expiration date. And you're good to go, okay? It's a no-brainer. So this is how we would do it with curl. And of course, this is how we would do it with Python. So as mentioned, all the models are OpenAI compatible. So you can use the vanilla OpenAI client. Once again, you just need to make sure that you enable HTTP2. Otherwise, you will get errors. Okay, and then the rest is just the chat completions API that I'm sure a lot of you already know. So let's switch to a notebook and run some examples. So today I'll show you Virtuoso Large and Coder Large. That's basically the code snippet you saw a minute ago in the UI. We need to define the endpoint. We need to have our API key ready and the name of the model. Okay, and that lets us create the OpenAI client. Great. So now we're ready to query. I just have a utility function to print out the streaming response. We don't have to do streaming, but just looks nicer in demos. So let's just get that function as well. And now let's run a first prompt. So write a short horror story in the style of H.P. Lovecraft. It should take place in the 20s in Antarctica. Write at least 2,000 words. Okay. And I'm setting streaming to true. Okay, let's just go and run this. And off it goes. So let's see how many tokens it's going to come up with. This could be a long one. It's still going, as you can see. It is the chatty model, and you can see the generation speed is more than adequate. I can't read that fast. Okay, let's wait for a little more. Okay, it ended up generating 3,500 plus tokens in 75 seconds. So that's a good 50 tokens per second, which is really more than you need. So I guess I'm going to save that story and read it over the weekend. It does look pretty cool. Okay, let's try something else. So here, I'm going to try something different. I'm going to try and leverage that huge context that we have. So I have the full text for Alice in Wonderland. And I have the full text for The Great Gatsby. So let's try to ask the model, to draw a parallel between the main characters of these two books. So obviously Alice and Gatsby, right? And I'll pass the full text for both books. All right, let's go. So we see we have over 70,000 words, so that's probably close to 100,000 tokens here. And processing was super fast. So here's the parallel between Alice and J. Gatsby: quest for identity and self-discovery. Yep, yeah, pretty clever. Dreamlike and unreal worlds. Yes. Naivety and idealism. The role of the narrator. The role of authority figures. Okay, well, again, that's probably worth a read, and I just took those books from my collection, so I didn't know you would find something really interesting. But there you go. Again, you can see, the speed in prompt processing and the speed in generation, and how articulate the model is. Okay, why don't we try Coder? All right, so set up our client again, streaming response. And let's try this one. Explain the difference between logic-based distillation and hidden state distillation. Show an example for both with PyTorch code with BERT Large as the teacher model and BERT-Base as the student model. Okay, completely made that up. Although I do have a distillation video for you, but that's probably coming out in the next few days. Okay, so let's try this. So a bit of explanation here, and then some code. Let's show the whole thing. Oh yeah, okay, got the name right, BERT Large, BERT-Base, nice. Load the models. Okay, create a very simple data set, but I didn't ask for anything here. And then, okay, run the forward pass. Yep, teacher outputs, student outputs, the distillation loss. That could actually work. I should try and run it, but yeah, I think all the right steps are here. Okay, and hidden state. Define a linear projection. Oh yeah, that's exactly how you would do it. Okay, yeah. All right, this should be working actually. You'll learn more about distillation in the upcoming video. But yeah, this is a pretty good answer, I think, and it's got good explanations, it's got good code, not bad at all. Okay, let's actually try to get the model to fix my stupid code. So here's my streaming function, and let's just ask, hey, improve the following code, which shouldn't be difficult, and explain what you did so that maybe I can learn a thing or two. So here's an improved version of the code. Yeah, I knew it. Okay. Oh yeah, Pythonic stuff. Yeah. Sorry. I still write, C style Python. Okay, fair enough. safe access to Delta content. Yeah, fair enough. Content could be missing and it would crash the function. All right, okay, all right. Yeah. Never said I was an amazing Python developer. And token count updates. Yeah, agreed. I might not be counting the tokens correctly. It could be an approximation. All right, fair enough. Fair enough for this demo. Okay, so again, keep playing with this, and obviously as we're doing this, we should see our usage going up a little bit. Yes, I think we have bigger numbers for sure here. All right, that's what I wanted to show you today. Our brand new model engine and the initial batch of models that are available there, either in the UI or through API calls with the OpenAI client. So go and have fun, sign up, let me know how you're doing. All questions welcome, and I'll see you soon with more examples and more models and the distillation video. Okay, my friends, thank you for watching. You know what to do. Until next time, keep rocking.